Hello, you're right. So what we're going to be doing today is we're going to be learning about immunisation. So that is your title for today, and we're going to explain how immunisation can protect us against disease. So by the end of this, all of you should know what immunity is, describe how immunisation protects the body against some diseases, and evaluate the reason for having something called the MMR vaccine when young. To begin with though, what you've got here are the words from last lesson, which have all been jumbled up. Okay, 1, 2, 3, 4. I want you to try and link these words. Firstly, unjumble them to reveal what the word is, and then which word describes these four things. Okay, so a substance that stimulates production of antibodies, a small single-cell organism that can reproduce quickly, a protein produced by the body's immune system that recognizes and helps fight infection, and finally, cells that fight infection in the body and are part of the immune system. Okay, so these are your four words, 1, 2, 3, 4. Unjumble them and then link them to their description. Off you go, please. I'll probably take you a couple of minutes to write that down. Okay, so the answers were a substance that stimulates production of antibodies. That was this one, antigen. A small single-cell organism that can reproduce quickly. That was this one, bacteria. A protein produced by the body's immune system that recognizes and helps fight infection, antibody. And finally, cells that fight infection in the body and are part of the immune system, white blood cell. That was this one. Okay, so immunization is a way of triggering the body's immune system to produce antibodies to pathogens. Now, once you've got antibodies, as you know from last lesson, they kill invading pathogens. So how do we get these antibodies? And of course, we need to answer the question, what does immune mean? Well, in a nutshell, it means being resistant to a disease. Now, there are a couple of ways we can become resistant to a disease. The first way is we actually get the disease and develop what's called a natural immunity, or the other way is called a vaccine. So I'm going to talk you through, firstly, how that happens, and then why we tend not to get sick again, because I did say we'd cover that from last lesson. So what I need you to do is, can everyone please pause the video and draw this graph into your book, and then we're going to explain it. So you've got number of antibodies in your blood and time along the bottom. You've then got a graph that shows this line and then a first and second infection. And please leave some space because you're going to need to add a few little extra notes to this as well. Okay, so pause the video and do that now, please. Okay, so welcome back. Now, the reason we tend not to get sick a second time once we've had a disease once is because of this. So just talk you through it. When we get an infection, what happens is our white blood cells have to develop antibodies to kill that pathogen. Now, when we meet a new infection, what happens is it takes our body a bit of time to figure out that pathogen and produce the correct antibodies to kill it. So often the response is quite slow. So what will happen is the number of antibodies will start to rise in the blood. We'll figure out how to kill it, and then the number of white blood cells start to replicate and copy, and eventually we fight off the infection. Problem is, while our body is figuring out how to beat that infection, in the meantime we tend to get sick. Okay, but as soon as our body has figured out how to beat that infection, it will make those antibodies and it will kill off the infection. Now, once the infection is dead, or all the bacteria or virus has been killed, the number of antibodies starts to drop. But you'll notice it doesn't drop all the way down to zero. Okay, white blood cells that beat that infection stay in our blood along with the antibodies. So the number of antibodies are always in our blood, ready for a possible second infection. Now let's just say the same bacteria or virus comes along again. What happens is it invades our body, but because we've already got white blood cells that know how to defeat it, they start to replicate and copy themselves very, very, very quickly within minutes. So what happens is, because you've got so many white blood cells so quickly, they make so many antibodies. The number of antibodies in your blood that beat the infection, that kill the infection, skyrocket. It goes up so quickly and kills the infection so quickly that you don't even know you've got sick. So we say we only get chicken pox once. Odds are you've actually been exposed to chicken pox several times in your life. But the reason you haven't got sick from it a second time is because your body was making antibodies so quickly that it killed that infection before it even made you sick. And then you'll notice the number of antibodies stays high in your blood for much longer here. First time it started to drop away quite quickly. Second time, it's like your body's on high alert and the number of antibodies stay high in your blood for a long time. So what I would like to do is just explain this graph in maybe 3 to 4 sentences about why it takes us a little bit of time to beat the bacteria or virus first time, why our number of antibodies never goes back to 0, and why we have such a steep increase compared to the first infection when we have a second infection. Okay, so pause the video and do that now, please. Now, the other way that we can stop ourselves from getting sick is what is called vaccination. And the person who discovered that was this person here, Edward Jenner. Now, there is a link. This link, you can't access it from this tutorial, but it is in assignments. Okay, this tells the story of Edward Jenner and how he came up with vaccination. So pause the video now, go into assignments and click on this link, please. And it's about 10 minutes long, and it'll tell you the story of how Edward Jenner came up with vaccination. Okay, so do that now, please. So, as you can see from what Edward Jenner did, he realised that people who got cowpox never seemed to get the much more horrible disease, smallpox. So he deliberately exposed someone to cowpox to prevent them getting smallpox. And that's essentially how a vaccination works. So, what you do is you inject someone with the antigens of a bacteria or virus, and what that does is or even a dead virus or bacteria, and what that does is these antigens, there they are, that triggers the immune system, and the immune system starts to make antibodies. So even though the bacteria and virus is not really there, its antigens are, and so the body still learns how to make the antibodies that kill it. So if you are ever infected with the real pathogen, it's able to kill it quickly. So once again, pause the video and have a quick look at this YouTube link. This is also in assignments. Now, also in assignments, I have put a blank comic strip and also the descriptions of that. So what you need to do is cut out the descriptions and put them in the right order on your comic strip, and then in the comic strip, in the space above where the descriptions go, you can draw a little picture showing what actually happens. Okay, so this task, by the time you print it off, cut it out, stick it down, will probably take about 15 minutes. Okay, if you're having problem cutting out, printing off and cutting it all out, then you can simply copy it up into your book and do the comic strip straight into your book. Okay, but that'll take you about 15 minutes. So download that from assignments now, please, and give that a go, and log back into the tutorial in about 15-20 minutes. Off you go. Now, a few years ago, there was a little bit of a scare because there was a vaccine called the MMR vaccine. Okay, and there's a lot of controversy about this. I'm just going to talk you through what actually happened. So, this is Dr. Andrew Wakefield, and he was the lead author of a controversial study which suggested there may be a link between MMR, autism, and bowel cancer, or bowel disease. And by the mid-1990s, Dr. Wakefield had started to consider whether there was a link between the 3-in-1 MMR vaccine and autism and bowel disease. So, MMR, what is it? why did people not want to give their children a vaccine? And why was the research discredited? Right. Now, once again, I'll put the link here in assignments. Click on that, watch the documentary, and then, or the link, and then answer these three questions. MMR, what is it? Why did people not want to give their children the vaccine? Why was the research discredited? Now, a couple of little things you do need to know for background. These are the measles rates, and you can see here 400,000 people, maybe by 940 getting it, but the numbers always went up and down, up and down, up and down, up and down. We got a measles vaccine the first time just before 1970, and the numbers started to drop. But then look what happened when we brought in the MMR vaccine. It went away to virtually nothing. This was the mumps, number of people that were getting mumps, and as you can see, it was quite high, and then it went up again in the 1980s. But then when the MMR vaccine was introduced, it went away to virtually nothing by the mid-90s. And then finally, rubella, which is another disease, quite high, went up and down a bit. But then as soon as we introduced the MMR vaccine, it went away to virtually nothing. But look what happened around about 1993. Okay, so most of you can probably realise what MMR stands for: measles, mumps, rubella. Okay, so it's vaccine against all three. Look what happened to the rates of rubella around about 1993, when a certain Dr. Wakefield was writing up or doing his research into this. Okay, so make sure you've answered those three questions, which were, these three questions about the MMR vaccine. Okay, and to do that, you'll need to click on this link, which is in assignments. Okay, so hopefully you've answered actually question one. What does MMR stand for? It stands for measles, mumps, and rubella. However, question 2, 3, and 4, I would like you to now, actually, and question 5 and 6, I would like you to have a go at answering these questions now. Actually, I'm just going to make these a little bit smaller. Bear with me a moment. Sorry about that. So just to finish off, I'd like you to answer these questions. So from question 2 to question 7, if you can. Why do we vaccinate against certain diseases? How do you eradicate a disease from the world? And have we eradicated any diseases? What is injected into your body when you have a vaccination? How does the vaccine give you immunity? Why do we need a booster vaccine? That's only true for some, but why do we need that? And then finally, why is it hard to vaccinate against the common cold? Okay, so have a go at answering those questions. Probably a good idea to actually write the questions down and then leave a little bit of space underneath to answer them. You will probably need to research the answers to these questions. That would probably take you about 15 minutes or so if you jump onto Google and try and find the answers for yourself. Okay, so good luck, and I'll be online if you need any help with that.